Today, I'm gonna tell you a very interesting story, the evolution of a scaling backend. Imagine you are the lead engineer at a company that's growing insanely fast. On day 1, you build your backend using REST APIs. Everything works perfectly. A few million users later, your mobile team complains that they are downloading very too much unnecessary data. So, you replace REST with GraphQL. Problem solved. And year later, your company breaks down the application into hundreds of microservices. Suddenly, the GraphQL becomes too slow for internal communication. So, you adopt gRPC. Then one day, your CEO walks in and says, "We are launching like chat and real time notifications next week." And that's when you realize neither REST nor GraphQL and nor gRPC is actually the right choice. You need WebSockets. So, if REST, GraphQL, gRPC, and WebSockets all are APIs, why did the company need all four? Now, that's exactly what we are going to uncover today. Most developers know how to call an API, but very few understand why an API was designed that way in the first place. Choosing the wrong API architecture can make your application slower, harder to scale, or even impossible to support real time features. So, today we will break down the four major API architecture designs, and at the end, I will give you a decision framework that interviews absolutely love. Let's start with the one you have definitely used before, the REST. REST stands for Representational State Transfer. Think of everything in your system as a resource. User is a resource, order is a resource, product is a resource. Each resource has its own URL. Users has its own URL. For product there's different, and for orders there's different. Notice something? We are interacting with resources using standard HTTP methods like get, post, put, or delete. Another important property is that every request is independent. The server does not remember what happened in the previous request. So, every request contains everything needed to process it. This is called statelessness, one of REST's biggest principles. But REST has one big problem. Imagine you are building an Instagram. You only need username, profile picture, and followers. But the REST API returns email, address, date of birth, login, and 20 more fields. You need 3 fields, right? You receive 25. This is called overfetching. The opposite also happens. You call one API for user details and another for followers, for comments, for posts. Now you made 4 network requests. Now that's underfetching. And that's exactly why GraphQL was invented. GraphQL means one endpoint and the exact data. So it was created by Meta. So instead of having dozens of endpoints for each resource, you need only one endpoint, and the client simply tells the server exactly what it wants. For example, as you see here, like my query looks like for this user ID, I want name, email, order, ID, status. I do not care about which is the request for each of its property. There is a single request going from here, and the response contains only those fields, nothing extra, no missing data, one request, exact response. So there is no overfetching, no underfetching, and that's GraphQL's biggest strength. It's especially useful for mobile apps where bandwidth matters. So REST API asks how everything about the user, and GraphQL asks tell me exactly what you need. So there is a huge difference. Next we are talking about gRPC. So why Google exactly created it? Imagine service A needs to call service B. Now with REST it sends JSON. The server passes JSON, processes it, created another JSON, and all that passing takes time. Google wanting something much faster. So they created gRPC. So instead of this JSON data, they use compact binary data using protocol buffers called protobuf. Binary is much smaller, much faster to serialize, much faster to deserialize, which means lower latency. So, instead of calling one endpoint, you define a function. In a proto file, something like get user, create order, update inventory, something like that. And our gRPC framework automatically generates client and server code. Then for your application, calling a remote server almost feels like calling a normal local function. So it takes care of networking, serialization, retries, response handling, everything behind the scenes. And gRPC supports four modes of communication. First is Unary. Unary means one request, one response. Simple. There is client streaming. Many requests, but there is always a one response. Next we have server streaming. One request, but there are lots of responses. And finally we have bidirectional streaming, means both client and server continuously send messages, perfect for live systems. So gRPC is standard choice for internal microservice communication at companies like Google, Uber and Netflix. Lastly, we have the WebSocket. Now imagine building WhatsApp or a stock market dashboard or an online multiplayer game. Would you send REST request every second asking any new message? No. Any now? No. That would waste enormous bandwidth. The client opens one persistent connection and the server keeps that connection alive. Whenever something changes, the server immediately pushes the updates. No polling, no repeated requests, and the communication becomes two-way. The client can send message anytime, the server can send message anytime, and both communicate instantly. And that's exactly how chats applications like WhatsApp, like sports, talk dashboard, all these works using this WebSocket connections. So, now let's summarize everything. REST. Simple, resource based, right? Best for standard CRUD APIs. GraphQL, single endpoint, client chooses exactly what it needs. Perfect for complex frontends. gRPC, binary communication using protobuf. Extremely fast, mostly ideal for internal microservice connection. Lastly, the WebSocket, persistent two-way connection like best for real-time communication. So, if you need to choose for your system which is the best API architecture, if you're building a normal backend, choose REST. If different clients need different pieces of data, choose GraphQL. If two backend services need blazing fast communication, choose gRPC. And if data needs to flow instantly in both directions, choose WebSocket. Simple, right? So now, whenever someone asks, should we use REST, GraphQL, gRPC or WebSocket, you will know the answer depends on what problem you are trying to solve. No, not now which technology is newer. So if you found this harmful, don't forget to like this video, subscribe to Scalecraft and let me know in the comments which API architecture do you like the most.